Today, let me explain why colonizing Titan might be better than colonizing Mars so far. Most researchers agree that the Moon or Mars are ideal targets for the first steps in colonizing the solar system. These destinations have a double advantage: close enough to the Earth, and its surface environment is not entirely independent of the current base. Mercury is too close to the Sun, among other possible destinations, with extreme temperatures and other seemingly insurmountable physical conditions. Venus is closer to us, but its atmosphere is toxic and becomes scorching hot due to the uncontrolled greenhouse effect. However, although the Moon and Mars seem to be relatively reasonable destinations, but they also have fundamental problems. None of these planets have magnetic fields or adequate protective atmospheres. This would force any future colonists to live in underground shelters to protect themselves from deadly cosmic radiation. Who wants to go to a whole new world? But can you only spend your life in an underground tunnel? In fact, no solution has been found for this problem yet. So much so that many scientists have recently begun to propose the ideal goal of attempting to establish the first human colony. Neither the Moon, not the red planet either, but the 2a6 Titans, Saturn's largest moon. This hypothesis sounds a bit unexpected, because the surface temperature of 2a6 is about -180 degrees Celsius. False pills and pills with hydrocarbons flowing into the ocean. However, scientists believe that in the long run, this is the only place where people can build their own colonies. Do they have a point? Titan is one of the most mysterious moons in the solar system. It is the second largest satellite after Europa, with its thick atmosphere and unique geological features. This moon of Saturn has attracted increasing attention from astronomers over the years. Unlike any other satellite, Tuwaliu has a climate model very similar to Earth's, with unique seasons and weather conditions. Can provide sunny days in that distant world, cloudy weather, windy or rainy days. Its surface has dunes, river deltas, attention lakes and oceans. We're still talking about average temperatures, an alien environment of about -180 degrees Celsius. Let's explore all its machine aspects for potential future colonization, without a dense enough atmosphere to protect, especially the effects of cosmic radiation. Any colony is best located underground. However, except for Venus, Earth V6 has by far the densest atmosphere of any rocky object in the solar system. This reduces the incident radiation to a negligible level. A planet's atmosphere is particularly effective at blocking the deadliest radiation, potential carcinogens of these radiations. On Earth, apart from the magnetic field, we are also protected by water in the atmosphere. But on Mars and the Moon, there is almost no atmosphere, and 2 meters of water is needed to block half of the incoming radiation, or 4 meters of soil. In order to prevent radiation, the atmosphere of the Earth is relatively small. The Earth is more than 50% thick, not to mention that Saturn's massive magnetosphere also provides shelter. It is no longer necessary to wear a pressurized suit on the soil V6 surface. Most rocky planets and all other moons in the solar system lack atmospheres. Even Mars' atmosphere is slightly denser than a vacuum. However, the rich atmosphere of TUV6 also means that the air pressure is more comfortable for human tourists. It's only 50% higher than Earth, totally controllable, so colonists can move around the surface. No need to wear uncomfortable pressure suits. A dense atmosphere allows greater heat exchange with the environment, hence the need for heated and ultra-insulated protective clothing. Of course, there are also public respirators. These needs can be met with our current technology. Titan has the most abundant nitrogen in the solar system, so the colonists just need to add oxygen, use existing nitrogen as buffer, create breathable air. In fact, the atmosphere of Earth V6 is already composed of more than 98% nitrogen. Our ratio is 78%. This makes it more similar to Earth's atmosphere than any other in the solar system. Although Titan does have no oxygen, but there is water, ice, and dust deposits beneath its surface. From there, oxygen for breathing and burning hydrocarbons can be easily obtained. Colonists need to live in sealed structures with controlled air. Additionally, access to advanced space services is critical for outdoor missions. Generating oxygen through water electrolysis or genetically modified plants could help create a breathable environment. Titan is the only celestial body in the solar system other than Earth known to have a large amount of surface liquid. It shows various terrains, just like our world. However, these liquids are not water, but methane and ethane. They are at -179. Remains liquid at a temperature of 5 degrees Celsius. Titan's surface is rich in solid and liquid hydrocarbons. Possess all the fuel needed for the colony. In fact, it contains hundreds of times more natural gas than all known reserves on Earth. Fortunately, in the earthy black oxygen atmosphere, these liquids are not even flammable. This makes them easier to convert into fuel, although invisible. But the water here is abundant. At temperatures twice as cold as the lowest on Earth, the water on Earth-6 surface will be permanently frozen and as hard as granite. Although Titan does not have an ocean similar to Earth's, but there is still a lot of frozen water on its surface and locked in the rocks below. Scientists think the shell of Tuwaliu is mainly composed of water ice. Extracting water ice shouldn't be too difficult. Titan's oceans could provide polymers for construction. Titan has a nearly unlimited supply of liquid and solid hydrocarbons. Also has everything the colonists need to build a permanent shelter. This orange world doesn't rely on wood, bricks, and metal like we do here on Earth. Instead, it's the perfect place to build sustainable surface structures using space-age polymers. The surface is protected from harmful radiation due to the thick atmosphere and Saturn's magnetic field. Colonists will be able to build surface habitats, rather than having to open huge underground shelters to avoid surface dangers. One of the main challenges is energy. Considering the distance from the sun and the dense atmosphere of Tuwaliu, solar panels are inefficiently used. The atmosphere of Tuwai-6 is about 10 times thicker than that of Earth. This means that the sky brightness of Tuwai-6 Zhengwu is likely to be very similar to that of Earth's Wanwang sky. One solution may be to use advanced nuclear reactors, or use local resources such as methane and ethane lakes to generate electricity. Additionally, alternative energy sources such as wind or hydrogen can be considered. Earth-6, the atmosphere contains a lot of nitrogen. We can use it as fertilizer, just like we are on Earth. Although Tuwai-6 itself is not a livable host, but it seems to contain everything you need to build a completely self-sufficient colony, considering that it is 1.2 billion kilometers away from the Earth. This will be crucial. Food production will be a serious challenge. Colonists need to develop greenhouse cultivation systems. The system can operate in cold temperatures as low as 6, and using methane as a source for plants. Furthermore, cultivating resilient microorganisms capable of converting local resources into food is important for ensuring sustained food supply is vital. Fortunately, Titan provided all the fertilizer the colonists needed to grow food. It is rich in light atmosphere, coupled with abundant methane and ammonia, can be used to grow crops and build a self-sustaining ecosystem. Let's take a look at the resources near Titan. The Saturn system has 62 moons and multiple rings made of billions of ice particles. Although Titan is by far the largest moon of Saturn, but the abundance of other objects in the Saturn system also presents enormous economic and exploration potential. For example, nearby Earth V2 hosts an underground ocean. The liquid is held in place by tidal friction caused by Saturn's immense gravity. At this time, it has become one of the most likely places in the solar system to discover alien life. The permanent base on Tuwaliu is very suitable for use as a submarine sweep base, a launch pad to many other destinations outside the solar system. We can even fly there. Exploring Thailand is by far the easiest. The most economical way is to fly with a pair of wings. Due to small size and low density, Saturn's surface gravity is only about 14% of Earth's, smaller than the Moon. Extremely high ratio of atmospheric density to surface gravity. It also significantly reduces the aircraft's wingspan required to sustain life. So much so that humans could sustain flight wearing a friendship suit easily produced with today's technology. No need to worry about falling from high altitude. Free fall acceleration here is 7 times lower than on Earth. The maximum fall velocity is 10 times lower than that of Earth. When falling from any height, the impact speed cannot exceed 18 kilometers per hour. It's all fun and exciting, but that certainly doesn't mean Musk or NASA will change their goals of colonizing Mars based on. Unfortunately, Tuvalu is a distant world. It would take a huge amount of money and major advances in aviation technology to get there. And in 20 years, we will just plant the flag on the mountain of the red planet Mars. Alien colonization is possible. When it comes to colonizing Tuvalu, we should realize that this is not just a short visit like the Mars mission. This meant building a ship specifically designed to carry large numbers of humans and women necessary for survival on the planet. Resource spacecraft. The spacecraft should be able to be self-sufficient on long journeys and can sustain human life for months or even years. Crew needs to be carefully selected and trained to meet the unique challenges of life on land in two-way. Astronauts should be multidisciplinary, possess comprehensive knowledge of engineering, medicine, and other disciplines necessary for survival. Before sending humans, Ningxi's approach is to dispatch advanced robot missions to do basic work. These robots should take on tasks such as building shelters, tasks such as gathering resources and preparing the environment for the arrival of human crews. Once you arrive at Tuvalu, the astronauts need to land safely and start building a colony. This phase will involve building habitat structures, producing food, and implementing it can be done under the unique conditions of Tuvalu. Functioning life knowledge system. All of this will cost a lot of money, and only if we find a more efficient propulsion technology than chemical rockets, all this can be achieved. It won't happen in 20 years, or even 100 years. Most likely after we draw conclusions from Mars colonization. It will be a few centuries before we really start thinking about colonizing Titans.